We are talking today about the 6 trig functions. That's the title of our notes. And you may have thought, I thought there was only 3, Mr. Marsh, sine, cosine, and tangent. But there are actually 6, and I'm going to introduce all 6, and there are only 6. I'm not going to add any more to this list. So here's what we have said. We first define sine and cosine in this picture. You have a right triangle with a hypotenuse of 1. You have some reference angle we'll call theta. And sine of theta is the distance or the length of the side length across from theta, right? So this is sine of theta, that length there, and this is the cosine of theta here. Let me remind you of an important thing that this picture shows us. What's the longest side length in this picture? The hypotenuse, which is 1. So will the sine or the cosine ever be bigger than 1? No. Will it ever be 1? Not when you have a triangle, but when you have the circle, the unit circle, there are some, like this 90 degrees or 0 degrees, there are some cases, special cases, where it will be equal to 1. So it'll be like this hypotenuse getting closer and closer and closer and closer to an edge. It's like the hypotenuse and the side length become the same thing, and so that's when it becomes 1. But it'll never be bigger than 1. Always remember that. Something we're going to have a problem today. That fact's going to help you. Okay. So then we also define tangent as the sine over the cosine. And that's where we stop. So each of these 3 have a reciprocal function attached to it. So for example, the tangent, right? The tangent is really over 1. So if I flip that over, that's what we call the reciprocal. So 1 over tangent theta, we call the cotangent. So that's one new one. And it's abbreviated COT. I'm going to write the actual full name here. So cotangent is its name. And so flipping, because tangent is sine over cosine, if we flip that fraction over, well, then that gives us cosine over sine. So if you flip anything over with the tangent, you get the cotangent. If you take the sine and flip that one over, you get 1 over sine. That's what we call the cosecant. CSC is how we abbreviate it, but it's spelled cosecant. Okay. And if we flip the cosine over, that's what we call the secant, abbreviated SEC. And so those are the additional 3 trig functions that we're going to have to remember that, okay, they're connected to the 3 that we know, sine, cosine, and tangent, and they're actually the reciprocals of them, right? It's easy to remember that tangent and cotangent go together because they both have the word tangent in them. But where it can get confusing is to remember that, oh, cosine goes with secant. You're tempted to say cosine goes with the cosecant because they both have the cos, but you just remember the cos don't go together, okay? The sine goes with the cosecant, the cosine goes with the secant. So there's our new info there. We can also, this new info gives us a new definition for tangent. We can now say that tangent is the reciprocal of cotangent. In a similar way, we could say that the sine is the reciprocal of cosecant. and that cosine is the reciprocal of secant. Okay. So no matter how you look at the reciprocals of each other, if you know one, you flip the other one over, and so on. Okay. So I'm going to give you some examples. We're going to first relate it to what we've been doing, just to help you practice this, just remembering what's what. And then I'm going to give you some new types of problems. Okay. So first example. Find all 6 trig functions of theta equals 90 degrees. So the first 3, sine, cosine, and tangent, were just like your homework last night, right? And in homework last night, you would locate 90 degrees. Here's 0 degrees, here's 90. And notice it's not in a quadrant, so we're not going to use a triangle, we're not going to use a reference angle. Instead, we're going to use that unit circle, which has a center at 0, 0, and a radius of 1. So here's 0, 0. If I move up 1 unit, what's the new coordinate that I'm at? So it's going to be 0, 1. So I haven't moved left or right, so x is 0. And I moved up 1, so y is 1. And then we know that the sine of 90 is going to be our x value, which is, no, I said it wrong, didn't I? All right. Sine is going to be a y value, which is 1. The cosine of 90 is going to be the x value, which is 0. And go ahead and find the tangent. I'm going to fix my y here. Tangent 90 is sine over cosine. Which is going to be 1 over 0, which is undefined. Okay. So now we have 3 more functions to add to this list. What's the reciprocal of sine? Cosecant. So here's what I want you to do. When you use the new trig functions, since this is the first time we're getting used to it, I want you to write the trig function, and I want you to write 1 over what it's the reciprocal of. So 1 over sine, and then you can look at sine and flip the answer over. Okay. So when you find the reciprocal of a number, it's easy if you had a fraction to start with because you flip the fraction over. If you don't have a fraction to start with, then make it a fraction and then flip it over. So like think of 1 as 1 over 1, right? And flip that fraction over and you're going to get 1 over 1, which is 1, right? So then the next one, reciprocal of cosine is going to be the secant, which is 1 over cosine. And again, we don't have a fraction. Cosine's 0, so make a fraction. What's a fraction that's equal to 0? 0 over 1, right? And then flip that over, and you're going to get 1 over 0, which is undefined. So the reciprocal of 0 is undefined. And then for the cotangent of 90 degrees, I should be writing 90 degrees. I'm writing theta here. is going to be 1 over the tangent. And that's, so we have undefined, but go a step before that and you see the fraction, 1 over 0, right? Take that fraction and flip it over, and you get 0 over 1, which is 0, okay? So here, remember that the reciprocal of 1 is 1, the reciprocal of 0 is undefined, and the reciprocal of undefined is 0, okay? That was example 1. Example 2, find all 6 trig functions for 120 degrees. So you first locate 120 degrees, which is in quadrant 2. Here's 0, we're moving counterclockwise on 120, right here. We draw a right triangle by dropping a perpendicular to the x-axis, and in that triangle make your hypotenuse 1, and find your reference angle, which is the difference, the positive difference between 180 and 120, which is 60. In our picture, what's our y value? Root 3 over 2. And what's our x value? Negative 1/2. Good. So we have to choose negative because we're in quadrant 2. We're on the left side of the graph. So make sure all your x values are negative over there. Okay. So then we can say, well, I know that the sine of 60 is my y value, which is root 3 over 2. The cosine of 6, sorry, I'm using the wrong angle. Let me fix that. It is true, but it's not the angle we're after. The sine of 120, the cosine of 120 is our x value, which is negative 1/2. Okay, so I want you guys, when you're doing this, even on this next homework, to, when you do sine and cosine, just to remind yourself, sines y, cosines x. I want to see that written in there. And just do it for sine and cosine. You don't have to do it for the other 4. Okay. When you do tangent, all I ask now for tangent on this homework is that you do the sine or cosine, just again to remind yourself of that part. And we can look back at these answers, and we saw that sine was root 3 over 2. Cosine was negative 1/2. You don't have to put x or y here on this. You can, but I'm not going to require that. And because both smaller fractions have the same denominator, we could reduce it to root 3 over negative 1, or negative root 3. Okay, so that's our tangent. Once you get the three basic trig functions, find their reciprocals. Reciprocal of sine is the cosecant. And when you write these reciprocal functions, write 1 over whatever it's the reciprocal of. So this one goes with the sine. And then just look at the answer and flip it over, right? So sine had root 3 over 2, so what are we going to put over here? 2 over root 3. Okay. You could put 1 over root 3 over 2, but that's a complex fraction, and you're welcome to do that. But then the next step is you take the bottom part of the fraction, flip it over, and you end up back at 2 over root 3. Because when you write 1 over sine of 120, that means take this, whatever the sine of 120 is, and flip it over. That's what that means. But we need to fix this. We can't have a square root of 3 in the bottom, or the denominator, so we need to multiply top and bottom by root 3 and get 2 root 3 over 3. And then the secant of 120 is 1 over the cosine, which is what? So when you flip over negative 1/2, you get negative 2 over 1, which is negative 2. And then the cotangent of 120 is going to be what? Yeah, so it's not a fraction, so picture it as a fraction, right? You can look at the one right before it and flip it over and you get negative 1 over root 3 and multiply top and bottom by root 3. You get negative root 3 over 3. And now we got it. All right, give me a second. Any questions? Okay. So number 3. Assume that theta is between 0 degrees and 90 degrees. What does that mean? What does that tell you? Okay, it's kind of like a reference angle because it's going to be positive and it's acute. But what quadrant are we in? So that's a quick way to just say, hey, we're in quadrant 1, right? And not only are we in quadrant 1, but yeah, we're not looking at all coterminal angles in there. We're just looking at acute angles in quadrant 1. Okay, so we're going to assume that that's theta. And let's see here. So if the cosine of theta is equal to 3/4, then what are the other 5 functions going to be? Okay. All right, so cosine is 3/4. Well, if we know the cosine is 3/4, we automatically get one more, which is what? The secant, yeah. So we know the secant, and whenever you use secant, write 1 over cosine, just to remind yourself, is going to be what? 4/3. So flip the cosine over. Okay. But the other ones, we don't know. We're kind of stuck. But we need to find them. Okay. So we still need to find the sine of theta cosecant of theta tangent and the cotangent. Well, really, if I find the sine, I find everything else. Because all 6 trig functions are really based on the sine and cosine. If you get the sine and cosine, you got the rest. So we have the cosine, we just need to find the sine. And so let's go back to the definition of sine and cosine. So in our quadrant 1, because it tells us that we're working between 0 and 90 degrees, is some theta, and we don't know what theta is. It's somewhere here. And I'm going to draw my right triangle. There's 1. We actually know that the reference angle is also theta. And the length here is the sine of theta, which is our y value. And our x value is the cosine of theta. So that's kind of from our definition and what we know with our picture. And we're given that the cosine of theta is 3/4, so I'm going to put that in my picture too. So I have a right triangle here. I know the hypotenuse, I know the base is 3/4. I just have one missing side, and if I find that missing side, I get the sine. How do we do that? If we have 2 sides, how do we find that third side? No. Yeah. Pythagorean theorem. A squared plus b squared equals c squared. Now, it gets a little, Pythagorean theorem with fractions. We could do that. But here's what I suggest. Draw a bigger version of that right triangle. So bigger version meaning it's similar. They both have a right angle and theta as an angle, but it's scaled up. And to scale up, we just multiply whatever we like. We get to pick the scale. So let's pick a number that we'd like to multiply these by so that we don't have any fractions. What would be an easy number to pick? 4. So if I multiply 3/4 by 4, I get 3. If I multiply 1 by 4, I get 4. And so we went to the right using a scale of 4. And I don't know what this third side is, and so I'm going to use a variable. And I don't want to use x or y because we've already been using them. So I'm going to use b. I don't know, a squared plus b squared equals c squared. Right? And so we can find b now with just using some integers, and then we can scale it back and find what sine is. That's the plan. So 3 squared plus b squared equals the hypotenuse squared. So b squared is 4 squared minus 3 squared, or 16 minus 9. So b is the square root of what? 7. Okay. So we have that. Now let's scale it back down. So if you scale up by multiplying by 4, how do you scale back down? Divide by 4. So like if I divide 3 by 4, I get my 3/4. If I divide 4 by 4, I get my 1. So what's the sign going to be? Root 7 over 4. And now we found our sine, root 7 over 4. And then once we get there, we don't need the picture anymore. We just work with our numbers. So cosecant is 1 over sine. So flip this over. Right? And we can't have the radical in the bottom, so we're going to multiply top and bottom by root 7. Tangent is sine over cosine. So I didn't give myself enough room here. I'm going to write down here. So I get root 7 over 4 divided by 3 over 4. Nice thing is that they both have a denominator of 4, so I could reduce it this way and get root 7 over 3. That's for my tangent. And then for cotangent, I got 1 over tangent. So that means flip your tangent over. 3 over root 7. And again, can't have a radical in the denominator. So 3 root 7 over 7. Okay, so lots of little steps there. And do we have any questions on this one? Still able to follow me on this? Okay. We'll test that out on the next problem. The next problem, I'll give you one like this and see what you do with it, okay? Okay, so then number 4, or example 4. I'm going to start the same way. I'm going to say assume theta is between 0 and 90 degrees. And this time I'm going to tell you that the cotangent of theta is 5/3. Find the other trig functions. All right, give it a try. All right, so let's walk through this. So we're given the cotangents, so for free we get what? The tangent. Okay. So I'm going to write cotangent of theta is 5/3. And so then the tangent in this case, because we're relying on the cotangent, I'm going to write this. I'm going to write 1 over cotangent of theta. That's true. They're reciprocals of each other. And that's why I could flip it over and get 3/5. Okay. So I got my cotangent and my tangent. Need more stuff though. And now I am assuming that somebody said, well, you know what? Tangent sine over cosine, right? It is. And that's important to know. So I'm gonna write that down here. So tangent is sine over cosine. So, and we know tangent is 3/5. Okay, and there's nothing wrong with that. That's true. Where you went wrong, you said because sine over cosine is 3 over 5, that means that sine has to be 3 and cosine has to be 5. That's not true. Because what if sine was 3 over 11 and cosine was 5 over 11? Wouldn't that reduce to 3/5? Right? So all this tells us is that there's a proportion going on. Okay? It doesn't tell us what sine and cosine are. We have two different variables, kind of not enough information to solve yet. Okay? But we're going to use that information to help us out here. And here's how. Go back to our picture. It tells us theta is between 0 and 90. So we're in quadrant 1. Make that right triangle. Here's theta. Hypotenuse is 1, because we need that hypotenuse of 1 so that our y value is going to be the sine of theta, and our x value is going to be the cosine of theta. And those are what we need. If we can find sine and cosine, we can find everything else. because of this proportion. What this proportion does tell me is that there is another larger triangle that's similar or proportional, where this is theta, and, well, sine corresponds with the 3, so I could put the 3 right here. Cosine corresponds with the 5, so I could put the 5 right here. That's what we are allowed to do, okay? And then in the bigger triangle, we can find the hypotenuse using Pythagorean theorem, and then figure out how to scale it back down. So I'm going to call this H for hypotenuse. I'll use capital H. And we got 5 squared plus 3 squared is our hypotenuse squared. So our hypotenuse is root 34. Okay. Now we have enough information to figure out, well, how can I scale down? Well, what am I going to do? Divide by root 34. Why do we know that? So we know the hypotenuse, we can compare the hypotenuse here, right? And so divide by root 34 to get your 1. So we're going to divide the 3 and the 5 also by root 34. And then we get our sine and cosine. So sine is going to be 3 divided by the root 34. And cosine is 5 divided by root 34. Now we have what we need. Yes, sine and cosine are not in the final form because we can't have the radical in the bottom, but we still can work with that. So I'm going to write, we'll put sine over here. It doesn't matter where we put it, but sine of theta is going to be 3 over root 34, which we got to fix that to 3 root 34 over 34. And the cosine is 5 over root 34, which is 5 root 34 over 34. I'm just multiplying the top and bottom of both of those fractions by root 34. Okay. So the reciprocal of sine is the what? What's it called? Cosecant, good. So the cosecant of theta is 1 over the sine of theta, which is, what do I write? What are you going to write? 34 over 3 root 34? You could, that's true. That's messy. Look, I got 2 fractions to choose from over here. Which one would you like to flip over? They're both going to work. I'm going to do the first one because that's going to put it in the form that I want. So I'm just going to write root 34 over 3. Okay. You could choose the second one, but then you'd have to do a lot of simplifying and you'd finally get back to what we just put there. And then the secant of theta is 1 over cosine theta, which is what? Root 34 over 5. And we did it. Woo! Okay. All right. One last one. This last one is for is for you heavy lifters, all right? Which is all of you, right? Okay. This last one's meant to make you stronger, okay? So here's what I'm going to ask you to do. Find only going to ask you to find one thing, so there's less work on this one, but more thinking, okay? Find the secant of angle C, and I'm going to give you a picture of a triangle. Here's A, B, C, and this is 20, this is 20, and this is 30. Find the secant of angle C. Okay, to make a right triangle, you're just going to, from point B, you're going to draw a perpendicular down to AC, right? Now, we're hoping it splits it in half, but we need to think about that. Does it really split it in half? Can anybody argue why it splits it in half? Okay, it is isosceles, so what does that mean? Why? Okay. What angle? So base angles are congruent by the isosceles triangle theorem, right? Okay, so why are the triangles congruent? Side what? Side angle, that'd be angle side side, which we can't do. Hypotenuse leg, all right. So by hypotenuse leg, we can say that the left and right triangles are congruent. Therefore, we can say it does bisect that side, and we got 15 and 15. So now we're just going to look at the right half. That's all we need. Where this is angle C, this is 15, this is 20. Now we got our right triangle. What's next? We need to find this. Find out what B is. Okay? So I'm gonna work through this with you because we are running low on time. So 15 squared plus B squared equals 20 squared. $400 minus 225. What is that? 175. So B is the square root of 175. Can we simplify that? That is 25 times 7. Right? So B is going to be 5 square root 7. Okay. All right. Disrupted from the bell. But here's what I would do next. I would scale that down to a hypotenuse of 1, and then I'd be able to have my sine and cosine, and I'd flip my cosine over to get my secant. I'll show you the answer right now. Homework's on your calendar. Here's what it looks like. Okay. You got 3 pages for homework, okay? Okay. Have a good week. You guys. Pause it.